Today we're going to look over the HMI that I created for the cooling tower project that we built in the lab. Here you can see the main screen. This here is where we can see all of our temperatures, the differences between them coming in and out, and the total difference between here and here. Over here we can see the frequencies of the motor at the bottom of the motors, our pressure sensor to ensure that our pressure doesn't get too high, our valve and its orientation. It's still open basically all the way straight through right now. Here's our fans on our cooler. When they're running, they'll be spinning. In this here we have our valve, which is the set point and the actual position. Here we have our heating pump where we can stop it, jog it, clear faults if there are any on the freak drive. Over here we can set our frequency to whatever we want it, between 15 and 80. Same with the cooling pump. This screen here is the fan settings page. It also shows the temps and the pressure of all of the sensors. In here we can see the settings for the fan, when it turns on, when it's to turn off, what the actual temperature is going in and out of the cooling side of the plate and frame. Here we can also disable the fan so we cannot use it. We can also test the fan to see if it works. As you can see, it changes up here also, showing that it's running. All of these look exactly the same, so that way we can keep some redundancy in our project. This here is our faults page. If there's a fault that is set up for the stack light that's on the machine, we can I put them here and they will flash on and off according to their settings. But we're going to go ahead and reset the freak drive before we get started. We're going to push start machine. See, the machine enable light comes on. Then we'll start heater. You'll see this motor going up fairly quickly to whatever we have it set as. And you can also see the heat temp in goes up drastically. Once this temp sensor hits 160 degrees, it will shut the heater off as a safety. And then once this temperature here becomes a certain temperature, the fans will start kicking on. This, you can see that the motor is green, showing that it's at the speed that it's set at. So if we go up to 50, it'll shut off and then it'll turn back on as soon as it gets up to 50. You can see that this is opening up the rest of the way to go through the cooler. That's based off of these temperatures here. If they're above 140 degrees, then it opens straight through. I'll show that in the PLC program later. As you can see, this just turned to 80 degrees. So that means that this fan will kick on. If this gets above 85, then this fan will kick on, and then 90, this one will. 95, this one will. As you can see, it's over 90 degrees now, so this fan kicked on, but this fan here didn't when it was supposed to at 85 degrees. So we're going to check our faults, and as you see here, it's faulted out. This here will be a basic rundown of my PLC, starting from the beginning. Obviously, we have our reset button for our freak drives when they fault out. Normally, we have to push the reset button when we first download into the PLC, as it loses communication for just a second, faulting out the freak drive. Down here you can see that we're machine enabled based on these parameters. If the machine is not enabled, it does this not ready bit, which goes into this timer that will turn this stack light on and off every 2 seconds based on this little flasher timer that I've created. As you can see now, the machine is enabled, so the stack light is solid. Here we have The run heater bit, this here is to tell the heater coil to begin. If the temperature is below 160, like I said, it'll be on, but as soon as it comes on, it shuts this off. That's the safety that I put in. The heater coil is ran by these three parameters, saying that we can run safely. If the heater is not on, it goes through this flasher like up here did, so we can flash this blue light telling the operator that the heater is no longer on to restart it if they need to. If the heater coil is on, this light is solid. If both heating pump and cooling pump are on, then a green light will be on. This here is how I'm starting my heating pump. It's either based off the run heater, or if the temperature is greater than 100 degrees, to continually cycle the water to help cool it down. We're stopping it either with the stop button on the HMI or on the cooling side. So once the cooling shuts off, that means that it's cool enough that we can shut this side off. Here's our pressure safety. This is based off of the pressure sensor that is on the machine. Obviously, if we have a fault, then we'll go through this flasher bit and flash the red light. Here's the timer for the heater to make sure that it's actually drawing amperage. Here's our cooling motor freak drive, start and stop functions. Obviously, if the temperature on the heat inside is above 90, we're going to turn the freak drive on to start the motor to start flowing water. As we know, there's going to be a spike in temperature. To stop it, we just stop it on the cooling side on the HMI. This here is how we're jogging our motors to test them if we would like to. Now into the fans. This is a very redundant thing, as there's 4 fans that do the same exact thing. If I was to do this again, I would probably do add-on instructions. They just would make it a lot easier. This here's how we're disabling the fan. This is how we're moving our temperature for when the fan turns on and off. This here is all the parameters to start the fan that's up by itself and shut it off. As you can see, we can disable it. We have to have the machine enabled. Make sure that the fan is actually running based off amperage being drawn through the relay. This is how it'll turn it on based on temperature. This is how it turns it off based on the temperature. Obviously, it's the same for 2, 3, and 4. As you can see here, though, fan 2 is not on. The fan 3 is based on this timer that is down here for our safety. These here are hooked to a little amp clamp telling the PLC if they're actually drawing amperage through them. If they are, then this bit becomes true, not timing up to fault out the coil. As you can tell, this one here is actually faulted out. Here's all of my timers for the faults. So that way, if something's faulted out, we can see it on the red light, and the operator or the person that designed it will know what is actually faulted. Down here, we're doing a bunch of math and moving for all of our frequencies, our temperatures in and out, for our 3-way valve. So these here are different percentages to open the valve based on the temperature that's going through the plate and frame. Here's a bunch more moves in math. Here's our frequency stuff to do the math on our frequency. Here's my math for the temperature displays that are here, these 3 displays here. This here is our first scan bit that moves all of these parameters into the fan settings when we first download to the PLC. That's pretty much it on that. Let's see how this is doing. As you can see, this temperature got up to 103 degrees. This is still open almost all the way. This temperature has dropped about 20 degrees now. Something that I do to cool it down faster is actually slowing down these pumps so that they have more time to cool and extract the heat. So if we go down to like 40 on this, then it will slow that pump down. But if we go to this and go to 35, it'll allow to push more water into the radiator, cooling it down better. But yeah, that's pretty much it on this. I hope the next person can get some use out of this video. I also hope that they learn as much as I did on this. Thanks.